So here we're going to compare wholes and fractions and see if we can use them interchangeably. And the way we do that is with things called proper and improper fractions. Sometimes they're called common fractions. And it's most easily shown by looking at some shapes. So here we have 4 shapes, and I've coloured in 3 of them, and I've coloured in half of the 4th one. So we've got one whole shape here, another whole shape here, another whole shape here. That's 3 whole shapes, plus half of a shape, or 3.5. And this is called a mixed number because it's got wholes and it's got a fractional part. Now we can make them all fractions, funnily enough, because we can split each of these into 2 so that all of these shapes have the same number of equally sized parts. So we can see here, this is in half, this is in half, this is in half, this is in half. I've selected 2 of 2 parts, that's this one, and 2 of 2 parts here, and 2 of 2 parts here, and 1 of 2 parts here. And I've got 1, 2, 3, 4, 5, 6, 7 parts, 2 plus 2 plus 2 plus 1, 7 parts. Each of them split into 2 sections. So this description 7/2 is actually the same as our description of 3.5. It's just written a different way. This is written as a mixed number. This is written as an improper fraction. And if we had 7/2, we could go backwards and work out this the same way. We would draw 2 out of 2, and we're not at 7 yet, so we haven't got 7 parts. Then we could draw another one. Now we've got 4 parts, that's still not 7. Then we've got 6 parts, that's still not 7, and then we'll be left over with 1 to make up our 7 parts. This would be all coloured in, that's 1, that would be all coloured in, that's 1, that would be all coloured in, that's 1, 1, 2, 3 wholes plus a half. So we're going to do that with this one. So if we had 5/3 and we wanted it as a mixed number, we know the parts should have 3 in it, so I picked a triangle and I split it into 3 parts. And then I coloured in 5 parts. 1, 2, 3, 4, 5. And had a look. How many holes have I got? That's obviously a hole because I've coloured in all the parts. This isn't a hole because I haven't coloured in all the parts. I'm going to write that as a fraction. So 1 hole plus 2 parts out of 3 is 1 2/3. Now, we could do this with a bit of arithmetic. So for 5/3, we might consider how many 3/3s exist, which would be how many holes, in 5/3. Well, that would be 1 hole, 3/3, plus 2 left over would give us 5 parts out of 3. And as soon as we get a 3/3, we can change that into a hole. So a hole plus 2/3 would give me 1 2/3. For 11/4, we could do the same thing. How many 4/4s exist in 11/4? Well, 4/4, that only gives us 4 parts, plus another 4/4, that would give us 8 parts, plus another 3/4, that would give us our 11. We've got 2 holes and 3 parts out of 4, which is where this comes from here. 2 holes, 3 parts out of 4. Another way to think about it is to treat the fractional symbol as division. So if you've got 11/4, that would be 11 divided by 4. How many 4s are in 11? There are 2. 2 4s are 8, and 3 left over. 8 plus 3 would be 11. And we could write that as a mixed number. 2 holes plus 3 parts out of 4 parts. And we could do some more of these. Let's have a look. If we had, I don't know, 18/5, that would equal to 5 parts out of 5, plus another 5 parts out of 5, plus another 5 parts out of 5. So that's 15, plus another 3 parts out of 5. Because 5 plus 5 plus 5 plus 3 is 18. And that would give us 3 holes, 1, 2, 3, where we'd be colouring in all 5 parts in our shape, plus 3/5, which simply is equal to 3 3/5. We could do 12/4. This is an interesting one. So 4/4, we're not at 12 yet, let's do some more, plus another 4/4, that gets us to 8. Hang on, that gets us to 12. We don't need any more. So in this case, 4/4 is 1, plus another 1, plus another 1, that would give us 3. No fractional part at all. Let's go backwards. So what if we had 3.5? So 3.5 would be 2 out of 2, plus another 2 out of 2. We've got 2 holes. Here's our third hole. Oops, that's not out of 3, it should be out of 2. Plus another hole, another part, but not a hole this time. So 2 plus 2 plus 2, that's our holes, plus our fractional bit, which is this bit here. Hole plus hole plus hole, plus the fractional bit, which is this bit here. So 1 plus 1, 2 plus 2 plus 2 is 6, plus 1 is 7. 3.5 is equal to 7 over 2. And 5 2/3, that would be 3 over 3 plus 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 2 over 3. 3, 6, 9, 12, 15, 16, 17 over 3. Now, the clever of you will be going, well, Mr. Milne, there's an easy way. You just go 5 times 3 plus 2. And you would be right. 5 times 3 is 15 plus 2 is 17. 5 times 3 plus 2. Or 3 times 2 is 6 plus 1 is 7. Or 4 divided by 12 is 3. Or 18 divided by 5 is 3 remainder 3/5. Absolutely. You could absolutely do it that way. But it's important to get an understanding of what exactly is going on when you do these quick methods of calculating things, in case you forget what you're doing and need to work backwards. So there you go, guys. I hope that helped.